So you guys remember what we did yesterday? If we had the same number over and over, it's a what kind of sequence? Girls? If we have the same number over and over, it's a what kind of sequence?
It's like our recursive.
Okay. Have you guys never heard this word before?
Arithmetic.
Arithmetic just means like basic math, like adding, subtracting, multiplying, dividing. Okay, it's an arithmetic sequence if you have the same number over and over again. The number you add could be negative, so it could be more like subtracting the same number over and over again. Okay, so that's called an arithmetic sequence. Today, guess what we're doing?
Non-explicit. Explicit.
Well,
Geometric.
we're doing that too. It's called a geometric sequence. A geometric sequence, which means guess what?
It's not the same.
Multiplying the same number over and over again.
Oh.
So yesterday when we had an added value over and over again, we called that the common difference. So it was like the difference equals, because that was the difference between each number in the sequence. In the geometric sequence, we have a multiplied value. So that number that you multiply over and over again is called a common ratio. So this one will have like an R equals. Okay, an example would be, so maybe I should have started with something easier, but how do we get from 8 to -4 to 2? Close. Divide by -2. Now dividing by -2 is the same thing as what? Multiplying by -1/2. So if you're not sure what the common ratio is, here's the easy way. I'm going to be doing this like a million times. Remember yesterday we did this minus this? Well, today to find the common ratio, you do this divided by this. So -4 divided by 8 is -1/2. That's the number you would multiply by over and over again. So that would be like your R equals. That's the common ratio. Okay. So yes, it is divided by -2, but we're going to think of it as times -1/2. We are going to do recursive and explicit definition and formulas and all that, but hopefully you remember how that goes. A lot more fractions today. That's what kind of makes it weird. 32 -16. So number 1 says determine whether or not each sequence is geometric. If it is, state the common ratio. So 32 -16, 4. Is this geometric?
Yeah.
How do we get from 32 to -16? -1/2 or divide by -2? Does that get us from -16 to 4?
No.
No. So this one is times -1/2, just like my example. But this one would be like times -1/4. So it didn't work. So it's not the same number over and over again. So this is no, not a geometric sequence.
Mr. Jordan, should I watch my dog stay? Yes or no?
What?
Should I watch my dog stay? Yes or no? Go on.
What your dog?
Walk.
Walk, huh? Sure.
How often? Yes or no? He said sure. Oh, sure?
Okay, number 3 just says -2, -2, -2. What do we multiply to get from there to there to there? 1. So is it a geometric sequence?
Yes.
Yes.
Yay.
Oh, we're just supposed to say yes, not geometric. What's the common ratio? 1. If you're not sure what the common ratio is, you just do the second one divided by the first one, or the third one divided by the second one. Number 5, cosine of pi. If you wanted to plug this in your calculator, you guys might remember this from the last chapter, you either need to change your calculator to radians, or you would need to change pi into 180. So cosine of 180 is like -1. Cosine of 2 times 180, 360, is +1. And that's kind of what you get. 1, -1, 1, -1, -1, 1, whatever. Okay, so is there a common multiplier that would get us from there to there to there to there to there to there? What could we multiply by to get from -1 to 1? -1. So, yes, this is geometric, and the common ratio is -1. How about number 4? What do you guys think about number 4?
It's like pretty okay.
So, log of 10, you could use your calculator to figure out what it is. Log of 10 is not worth 10. Log of 10 means 10 to the what equals 10. So it's worth 1. Log of 100 means 10 to the what is 100. That's worth 2. Log of 1,000 means 10 to the what is 1,000. It's worth 3. So that sequence is just 1, 2, 3, 4, blah, blah, blah. So is that a geometric sequence? No, the pattern is +1. It's not times 2 or anything, because it doesn't work on all of those. Number 7, state the next 3 terms of the geometric sequence. Okay, how do we get from 9 to 6?
Three.
Amazing. No. Yeah, if you weren't sure what the multiplier was, do you remember how I said to find the multiplier?
6 divided by 9.
Yeah, 6 divided by 9, which does not come out pretty. It's just 2/3. So we need to find the next 3 terms. So we need to do 6 times 2/3, which is 4. 4 times 2/3. Here's what I'm doing in my head. 4 times 2, 1 times 2. 8/3. 8/3 times 2/3, so it's just 8 times 2 and 3 times 3. So it's 16/9. Whoops. Anyway, these are the next 3 in the sequence.
How would you think that Mr. George?
And you just have projectiles up here so I can throw them at you.
Me, she was singing too.
But like you're more annoying by something one word.
Okay, 19 is pretty weird. How do we get from 14 to 10?
19.
Or,
9.
Actually, there's codes
huh?
Wait,
Well,
that's wrong.
We do 10 divided by, did I say 19?
Yes.
We do 10 divided by 14, which is just like 5/7. Okay, it's gonna be kind of weird. So 10 times 5/7 is just 50/7. And 50/7 times 5/7, 50 times 5 is 250. 7 times 7 is 49. And 250 49ths times 5/7. 250 times 5 is 1250. And 7 times 49 is... So it's just kind of weird. It's a little bit weird.
Number 8's also a tad bit strange.
8's strange in a different way,
A little bit.
I have a question.
yeah. Yep.
Which one is the hardest question on this?
What's
Is
wrong?
I don't know. I don't know. There's nothing that stands out to me. All right, number 15. Write an explicit formula. You guys remember? Oh, wait, I skipped 11. What the heck? Write a recursive formula for number 11. 9, -3, and 1. Okay, so the first thing we need to do is find the pattern. What are they multiplying by over and over again? Huh? Not quite. Combine those two answers. -1/3. Okay, it's like -3 divided by 9, right? So it's -1/3. Okay, To write a recursive, this is the one that's defined based on the previous term, a sub n minus 1. Remember? So you're supposed to say what the first term is. So a sub 1 is 9. And then you're supposed to define the nth term based on the previous term. So what are we doing to the previous term to turn into the new term? We're multiplying it by negative 1/3. So the new term, a sub n, is going to equal negative 1/3 times the previous term. What have we been calling the previous term? What comes right before? Right. What comes right before a sub n is a sub n minus 1. And we need to do that times negative 1/3, so the most natural place for that to go would be right there. And that's it. Hey, maybe Anya wants to sing sometimes. You ever think of that?
Yeah.
Anya, I know you're a pop star just waiting to bust out. You see at home, Anya? How old's your sister?
That's good, Forrest.
I don't think I knew you had a sister. Any brothers? No. What?
Yeah, that's so
Caden didn't catch that.
She sings louder. There's no comments.
Her singing is awesome. Just breathtaking.
Face.
Like, you think they don't actually.
Straight up from
The ratio of her singing to your singing is 1 to a
You're
million,
from Tallahassee.
Okay.
which is also the ratio of my irritation.
Where's Tallahassee?
Whoa.
Directly.
That's Florida. Yes. I think I'm Tennessee. It's from Florida because
The
capital.
majority of the people that love you. So, are you sure? I'm sure Willow loves you. Yes, I do. Ava has no comment for us. She has no comment. She doesn't even want to comprehend what you said. Yeah. No, oh, yeah. She hasn't been
Yeah.
so far. She does. She just won't say it.
That's what you just started just saying that.
The whole
I'm not
person
wrong.
how much I like
What
it.
you said was
Okay.
That's 3 people.
Okay.
Okay.
Reimagine.
3 out of like
Grant, you said the
9.
same before.
You are much beloved.
And then you
11.
Okay,
Even
how,
worse.
how do we get from 16 to 12? Or how do we figure it out?
12 over 6.
12 over 16, that's right. 12 divided by 16 is 3/4. Okay, so 12 is 3/4 of 16. So we're supposed to write a recursive. So we define the first term as 16. The nth term is going to be 3/4 of the previous term. So a sub n equals 3/4 of a sub n minus 1. Got it? Clear as mud?
No.
Mr. Jordan, like, do you think that we're a normal class for the most part? Other than like a few loose streams? Caden, watch out! They're looking at you. Mr. Smith.
Olivia's the type of person to say it's not funny and
Maybe
she's
more
like,
like
About it for like 20 whole minutes. And the most obnoxious laughing the whole time.
That's so Alright.
And then later he's like, it wasn't even that funny.
That's what you get from knocking my door. Who? Like, no, it wasn't me. Like, what? I just get the friend.
Table.
Yeah. You are. I'm gonna. If I sit right now,
All right. So in 15, we're supposed to do the explicit version. They say the first term is 2.
So
The,
awful.
the common ratio is 5. So that means we're multiplying by 5. So it's like 2, 10, 50. We're doing times 5. Okay. For explicit, you have to back up 1 step. So if the pattern is times 5, how do I find out what came right before this one?
Divide by.
Divide by 5. 2 divided by 5 doesn't work very well, it's just 2/5. So for the explicit formula, you start at 2/5, and then to move forward, you would need to multiply by 5. So it's times 5. How do we multiply by 5 over and over though?
Times whatever number.
Exponent.
Exponent, exactly.
Okay.
So
That ugly idiot.
in this, all right.
That's exactly like the hashtag.
Hashtag she called me batty ugly.
The girl's gonna start crying. She's like,
Somewhere there's a pregnant lady crying.
Such horrible.
she sheds a tea.
Okay, so we want to multiply by 5 over and over again. Shh, that means we need our variable to be in the exponent. Because we want to multiply by 5 once to get the first term. We want to multiply by 5 twice to get the second term. So if we plug in 1 here, this should give us 2. When we plug in 2 for n, that should give us 10. And so on. But yeah. All geometric sequence explicit formulas look something like this. Variables in the exponent.
Okay.
You have a starting number that you have to back up 1 from that. And then your common ratio goes right there, variable is in the exponent. Okay, let's try it again. Number 17. This one is 24, negative 18.
I just saw.
Okay, so how do we get from there to there? Or what do I do to figure it out? How do I figure out how to get from divide? Negative 18 divided by 24. If you divide those by 6, that's negative 3/4. So the common ratio is negative 3/4. Okay, what we need to do is figure out what came before, well, if there was something before 24, what would it have been? So if to go forward, we have to multiply by negative 3/4. To go backwards, we would have to divide by negative 3/4. So 24 divided by negative 3/4 would be the thing. And that would come out as negative 32. Okay, so on our formula, I'm going to start at negative 32. And then what am I multiplying by? How do we step forward? That number, negative 3/4. And then I want to multiply by that over and over again. So my n is going to go in the exponent. That's how you multiply by the same number over and over. All right.
It's a splendid day today.
19. So the directions on 19 are identify each sequence as arithmetic and state the D, the common difference. Geometric, state the R, the common ratio, or neither. So what is the pattern on number 19? 2, 4, 6, 8. What's the pattern?
2.
What 2? How do we get from 2 to 4 to 6 to 8? Adding plus 2. So if the pattern is plus 2, what kind of sequence is it? Arithmetic. And the plus 2 is called the common difference. Because 2 is the difference between 4 and 6, and 6 and 8, anyways. So we're supposed to put D equals 2. Okay, on 28 it goes 2, 4, 8, 14. What is the pattern? Times 2?
Yeah.
That almost works. It works on the first and the second jump, but not that. 8 to 14 is not times 2. There is a pattern. Does anybody see it? It's an adding pattern.
But it's not arithmetic.
Okay, but it's not arithmetic because it's not.
It's like +2, +4, +6.
Yeah. So, but arithmetic has to be the same thing, so we're just gonna put neither.
You know, I think there's something wrong with this ratio.
Okay, 23, 2y, 3y, 4y. Alright, how do we get from 2y to 3y to 4y? Plus y, right? 2y plus y is 3y. 3y plus y is 4y. So if we're adding y over and over, it is an arithmetic sequence. Have you guys never heard like the phrase reading, writing, and arithmetic?
But it's still.
Okay, and the common difference, the number we're adding over and over, is y.
Mr. Jordan, what? What? No, sorry. What does the math teacher say on Halloween?
What? Trick or treat.
I wish for trick.
Did you just make that up right now?
Brother.
Dude. I think it's how you know that you failed to pass. Like
If by really good, you
class
mean really
is
bad.
like, That's not offspring.
The pause is
What did I do wrong?
Okay, so did you guys notice that 2 of those were arithmetic? So guess what the evens are going to be? Geometric, yeah. So they're going to have a common ratio instead of...
I hate that. Okay, girl. These numbers